1a, we were asked to differentiate f of x equals 3 to the 2x. Well, we have a base and an exponent. In the case where the base is a function and the exponent is a constant, we have a power function and we use the power rule to differentiate. But what we have is a constant in the base and a function in the exponent. Therefore, we know that this is an exponential function. And you'll recall that if y equals a to the u, here a is a constant and u is some function, then y prime is going to be a to the u times the natural log of that base times u prime, the derivative of the exponent. So in our case, the base a is 3 and the exponent u is 2x. So we'll have a to the u times the natural log of the base times the derivative of the exponent, which is 2. And that's the correct answer. 3 to the 2x times natural log of 3 times 2. 1b, we are asked to differentiate g of x equals 2 to the x times x to the 7th. We have a function here and another function here, and the operation between the two functions is multiplication. Therefore, we are going to want to use the product rule. Now, let's discuss which sort of functions we have. Each of them has a base and an exponent. In the first function, the base is a constant and the exponent is a function. In the second factor, the base is a function and the exponent is a constant. This is a power function. So we're going to use the exponential function to differentiate the first factor, and when we differentiate the second factor, we'll be using the power rule. Yes, that's right. Alright, so using the product rule, we'll have the first factor times the derivative of the second factor. Using the power rule, we get 7 times x to the 6th. Now we need to add to that the derivative of the first factor, which would be 2 to the x times the natural log of the base times the derivative of the exponent, but that's going to be just 1. Then we have the second factor, x to the 7th. Now, if you like, we can take out all the common factors. I see a common factor of 2 to the x and x to the 6th. So removing that from this term, we're going to be left with just 7, I believe. And in the second term, we're going to be left with natural log of 2 times 1 times, looks like x. In 1c, we are asked to differentiate h of x equals sine of 2 to the x. Here we have a composition of functions. We have a function inside of another. The outer function is the sine function, and the inner function is 2 to the x, an exponential function. So we're going to use the chain rule. So we need to differentiate the outer function, the sine. That'll be the cosine. You remember that we leave the inner function alone. And then we multiply this by the derivative of the inner function. Well, this is an exponential function, so we rewrite the function 2 to the x. We multiply by the natural log of the base, and then by the derivative of the power. So I'm going to write that as 2 to the x times the natural log of 2 times the cosine of 2 to the x. 1d, we are asked to differentiate the log of x squared plus 1. This logarithm does not have a base, so it's understood to be the common logarithm, that is the base 10 logarithm of x squared plus 1. So let's write this in terms of natural logs. It's the same thing as 1 over the natural log of 10 times the natural log with x squared plus 1. Now, this is a constant. So when we differentiate, we will have this constant, 1 over natural log of 10, times the derivative of this function, natural log of x squared plus 1. Alright, so we'll have 1 over the natural log of 10. And now to differentiate the natural log of a function, remember that what you want to do is write 1 over the function times the derivative of the function that you're taking the natural log of. So I'm going to rewrite all of that as 2x over the natural log of 10 times x squared plus 1. 1e. We are asked to differentiate the log base 2 of the quantity x squared times e to the x divided by the square root of x squared minus 3. I think this is a perfect opportunity to use the rules of logarithms to break this log up into simpler logs. So let's write this as the log base 2 of x squared plus the log base 2 of e to the x minus the log base 2 of the square root of x squared minus 3. But I'm going to rewrite that as x squared minus 3 to the 1/2 power. Now the next thing I'm going to do is rewrite these base 2 logarithms in terms of natural logarithms. Well, so they're all base 2 logarithms, so I'm going to write them as the natural log of whatever function we're taking the log of divided by the natural log of 2. In fact, there's going to be a 1 over natural log of 2 in each one of these terms, so I'm just going to write that out here at the beginning. And then we'll have the natural log of x squared plus the natural log of e to the x minus the natural log of x squared minus 3 to the 1/2. And I'm further going to simplify these. The log of x squared, the natural log of x squared, can be rewritten as 2 times the natural log of x. The natural log of e to the x, that simplifies. That's just x. Remember, the natural log of e to the a is the same thing as a. And then here this power can come out to the front, and we'll have 1/2 the natural log of x squared minus 3. So we have not differentiated yet. That's what we're going to do next. So remember that the natural log of 2 is a constant. Since 2 is a constant, therefore 1 over natural log of 2 is a constant. So what we're differentiating is a constant times a long function. When we differentiate, we will bring the constant down and multiply it by the derivative of this long function. So here we have 2 times the derivative of natural log of x, that's 1 over x. The derivative of x is 1, minus 1/2, 1 over x squared minus 3, but now we need to use the chain rule because we have the natural log of a function. We have a function inside a function. So we multiply by the derivative of x squared minus 3, that's 2x. And we simplify. We'll have 1 over the natural log of 2 times 2 over x plus 1. I see 2's that will go away. So it looks like we're going to have just x in the numerator there divided by x squared minus 3. 1f, we were asked to differentiate s of t equals the arc sine of the quantity 5t plus 1. Here we have a function within a function, so we're going to be using the chain rule. This is also the arc sine function, and you remember that the derivative of the arc sine function is given by this formula. If y equals the arc sine of u, where u is some function, then y prime is equal to 1 over the square root of 1 minus u squared times u prime. So again, the u is what you're taking the arc sine of, and u prime is the derivative of that thing. So in our case, we'll have s prime of t is 1 over the square root of 1 minus the square of 5t plus 1. That's this part. And now we need to multiply by u prime, which is going to be the derivative of the inside function, and that's 5. And I will rewrite that as 5 over the square root of 1 minus 5t plus 1 squared. I don't really see any good reason to expand this perfect square. We're not going to get anything that we can simplify, and so I think I'll leave it as it is. 1g. We are asked to differentiate the square root of the arctangent of x. I'm going to rewrite that as the arctangent of x, all raised to the 1/2 power. So what we've got then is a composition of functions. We've got an outer function, which is the part where we raise something to the 1/2 power, and then there's the inner function, which is the arctangent function. So we're going to use the chain rule. We'll have the derivative of the outer function. That'll be 1/2 times the arctangent of x to the negative 1/2 power, because we need to subtract 1 from that power. Now, we need to remember what the derivative of the arctangent function is. Well, remember that if y equals the arctangent of u, where u is some function, and in this case u is just a simple x, then y prime is going to be 1 over 1 plus u squared times u prime. So again, so this is just the derivative of that function in case we need to use the chain rule. All right. So in our case, what we'll our u is just x. So we'll have 1 over 1 plus x squared, and then u prime is just 1. Pardon me. I'm going to rewrite this expression of the negative exponent. So we'll have 1 over 2, and then in the denominator you'll have arctangent of x to the 1/2 power, and then just times 1 over 1 plus x squared. And if you like, you can rewrite that as 1 over 2 times the square root of the arctangent of x times 1 plus x squared.